In previous class, postulates of Bohr's atomic model. First of all, Rutherford's atomic model and postulates of Bohr's atomic model are completed in previous class. Rutherford's atomic model, next postulates of Bohr's atomic model are completed in previous class. And
Sir,
next,
ఒక్క నిమిషం 1 minute.
next drawbacks. Drawbacks of Bohr's atomic model. Drawbacks of Bohr's atomic model. Okay. So in previous class, postulates of Bohr's atomic model are completed. And next one, drawbacks of Bohr's atomic model. Drawbacks of Bohr's atomic model. So first one, Roman number 1. Bohr's atomic model. Bohr's atomic model could not explain. Bohr's atomic model could not explain Zeeman effect. Bohr's atomic model could not explain Zeeman effect. Zeeman effect. First drawback of Bohr's atomic model. That is, Bohr's atomic model could not explain Zeeman effect. So what is meant by Zeeman effect? Very simple. Splitting of spectral lines. Splitting of spectral lines. Splitting of spectral lines in the presence of magnetic field. In the presence of magnetic field is called Zeeman effect. Okay, so Bohr's atomic model could not explain Zeeman effect, and Zeeman effect means splitting of spectral lines in the presence of magnetic field. So first drawback of Bohr's atomic model. And second one, same Bohr's atomic model could not explain Stark effect. Stark effect. Bohr's atomic model could not explain Stark effect. So first one, Zeeman effect. Next one, Bohr's atomic model could not explain Stark effect. So what is meant by Stark effect? So very simple, splitting of spectral lines. Splitting of spectral lines. Splitting of spectral lines in the presence of electric field. In the presence of electric field is called Stark effect. Okay, so Stark effect means splitting of spectral lines in the presence of electric field. Electric field is called Stark effect. So Bohr's atomic model could not explain Zeeman effect and Stark effect. So Zeeman effect means splitting of spectral lines in the presence of magnetic field. Stark effect means splitting of spectral lines in the presence of electric field. In first one, magnetic field, and second one, electric field. Next, the third drawback. So Bohr's atomic model could not explain a fine structure of hydrogen atom. A fine structure of hydrogen atom. So Bohr's atomic model could not explain a fine structure of hydrogen atom. Third drawback of Bohr's atomic model. Third limitation of Bohr's atomic model could not explain a fine structure of hydrogen. And fourth drawback is Bohr's atomic model could not explain de Broglie's, scientist name de Broglie's dual nature. De Broglie's dual nature. Dual nature means particle nature and wave nature. Two characters, particle nature and wave nature. So Bohr's atomic model could not explain de Broglie's dual nature of electron. So these are drawbacks or limitations of Bohr's atomic model. Four drawbacks. First drawback is Bohr's atomic model could not explain Zeeman effect. And Zeeman effect means splitting of spectral lines in the presence of magnetic field. And second drawback, Bohr's atomic model could not explain Stark effect. Stark effect means splitting of spectral lines in the presence of electric field. Next, the third one, Bohr's atomic model could not explain a fine structure of hydrogen atom. And fourth one is Bohr's atomic model could not explain de Broglie's dual nature of electron. Dual nature means particle nature and wave nature. So Bohr's atomic model could not explain de Broglie square layer electron. Okay, so postulates of Bohr's atomic model. Next, drawbacks are limitations of Bohr's atomic model. 4 drawbacks. So, Zeeman effect, Stark effect could not explain the fine structure of hydrogen atom and could not explain de Broglie's square nature of electron. So, these are drawbacks or limitations of Bohr's atomic model. Here, so postulates of Bohr's atomic model. Next, drawbacks of Bohr's atomic model. Okay, and next heading. Next one. Next one, very important concept. So Rutherford's atomic model completed, Bohr's postulates completed, and the drawbacks of Bohr's atomic model completed. And next important concept that is hydrogen spectrum. Hydrogen spectrum. Hydrogen spectrum. Very important. Hydrogen spectrum. Hydrogen spectrum. Total 5 series. First one is Lyman series. Lyman series. Lyman series. Second one is Balmer series. Second one is Balmer series. Balmer series. Lyman series. Balmer series. Third one is Passion series. Third one is Passion series. Lyman series, Balmer series, Passion series. Fourth one is Bracket series. Bracket series. Fourth one is Bracket series. Bracket series. Next, fifth one is Fund series. Fund. P silent letter. So Fund series. Fund series. Okay. So 5 series. So name of the series: Lyman series, Balmer series, Passion series. Next one, Bracket series. Next one, Fund series. 5 series: Lyman, Balmer, Passion, Bracket, and Fund series. First of all, spectral diagram. Very simple diagram. First of all, okay. So see, n is equal 1. Next, n is equal 2. N is equal 3. Okay. N is equal 4. Next, n is equal 5. Next, n is equal 6. Next, n is equal 7. Okay. So n is equal 1, 2, 3, 4, 5, 6, 7. Okay. So first of all, the transmission of energy of an electron. The transmission of energy of an electron from any higher orbit level to any higher orbit level to. That means 7 to 1, 6 to 1, 5 to 1, 4 to 1, 3 to 1, 2 to 1. 2 to 1. So say Lyman series. Lyman series. So first one is Lyman series. Next one, the transmission of energy of an electron from any higher orbit level to n is equal to n is equal to. That means 7 to 2. Next, 6 to 2, 5 to 2, 4 to 2, 3 to 2, 3 to 2. So say Balmer series. First one is Lyman series. Second one is Balmer series. Next one, the transmission of energy of an electron from any higher orbit level to n is equal to 3 produces. N is equal to 3 produces. That means 7 to 3. Next, 6 to 3, 5 to 3, 4 to 3. So first one Lyman, Balmer. Next, Passion. So you see Passion series. Passion series. Next one. 7 to 4, 6 to 4, 5 to 4. 5 to 4. So see Bracket series. Bracket series. Bracket series. And last one, 7 to 5, 6 to 5. So see Fund series. Fund series. Fund series. So this is hydrogen spectrum. Hydrogen spectrum. So Lyman series UV region, ultraviolet region, Balmer series, visible region, visible region. Next, passion series, IR region, IR. Then bracket series, IR region. Then fund series, IR region, IR region. So Lyman series region, ultraviolet UV region. Second one, visible region. Third one, IR region. Fourth one, IR region. Fifth one also IR region. IR means infrared rays. Infrared rays. Okay, here. So first of all, five series: Lyman, Balmer, passion, bracket, fund series, and spectral lines. First of all, what is meant by Lyman series? What is meant by Lyman series? Very simple. The transmission of energy of an electron. The transmission of energy of an electron from any higher orbit level to any higher orbit level to n is equal 1 produces. N is equal 1 produces spectral lines. Spectral lines in UV region. UV region is called Lyman series. That means 7 to 1, 6 to 1, 5 to 1, 4 to 1, 3 to 1, 3 to 2 to 1. From any higher orbit level to n is equal 1 produces spectral lines in UV region. UV region or ultraviolet region is called Lyman series. Lyman series. Second one, Balmer series. What is meant by Balmer series? Same, the transmission of energy of an electron from any higher orbit level to n is equal to produces spectral lines in visible region is called Balmer series. Balmer series. So the transmission of energy of an electron, that means 7 to 2, 6 to 2, 5 to 2, 4 to 2, 3 to 2. The transmission of energy of an electron from any higher orbit level to n is equal to produces spectral lines in visible region is called Balmer series. Balmer series, clear. Next, what is meant by passion series? Very simple. The transmission of energy of an electron from any higher orbit level to n is equal 3 produces. N is equal 3 produces spectral lines in IR region. IR region is called passion series. That means 7 to 3, 6 to 3, 5 to 3, 4 to 3. So passion series. Next one, bracket series. The transmission of energy of an electron from any higher orbit level to n is equal 4 produces spectral lines in IR region is called bracket series. Bracket series. And last one is fund series. The transmission of energy of an electron from any higher orbit level to n is equal 5 produces spectral lines is called fund series. Fund series. So n is equal 1 produces spectral lines in UV region, that is Lyman series. N is equal 2 produces spectral lines in visible region, that is Balmer series. N is equal 3 produces spectral lines in IR region, that is passion series. N is equal 4 produces spectral lines in IR region, that is bracket series. N is equal 5 produces spectral lines in IR region, that is called fund series. So first one is UV, ultraviolet region. Second one, visible region. And third one, IR region. Fourth one, IR region. And fifth one also IR region. Okay, so Lyman series, Balmer series, passion, bracket, and fund series, and spectral lines. And what is meant by Lyman series? What is meant by Balmer series? What is meant by passion series? What is meant by bracket series? And what is meant by fund series? And spectral region, UV region, visible region, IR region, IR region, IR region. Okay, so C is hydrogen spectrum. Hydrogen spectrum. So Lyman series means the transmission of energy of an electron from any higher orbit level to n is equal 1 produces spectral lines in UV region. N is equal 2 produces spectral lines in IR region, Balmer, passion, bracket, fund. So C is hydrogen spectrum. Hydrogen spectrum. Clear? Right. Next. 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 Very simple. First of all, name of series. Name of series. Next, N1 value. Next N2 value. Next one spectral region. Spectral region. Spectral region. Okay. So first of all, name of series here. Next N1 value, right? Next N2. Next spectral region. Spectral region. So first one is Lyman series. Lyman series. Second one Balmer series. Balmer series. Lyman series. Balmer series. Next one Passion series. Passion series. Passion series. Next Bracket series. Bracket series. Bracket series. And last one is Fun series. Last one is Fun series. Okay. So name of series: Lyman, Balmer, Passion, Bracket, Fun series. Next N1 value. So N is equal 1 produces spectral line. So in Lyman series, N1 is equal to 1. Next Balmer series, N is equal to 2. So N1 is equal to 2. Next Passion series, 3. Bracket series, 4. And Fun series, 5. Okay. So in Lyman series, N1 value 1. Balmer series, N1 value 2. Bracket series, N1 is equal to 3. Next, Passion series, N1 is equal to 3. Bracket series, N1 is equal to 4. Fun series, N1 is equal to 5. 1, 2, 3, 4, 5. Next one, N2. N2 is always greater than. N2 is always greater than that of N1 value. N1 value. N2 is always greater than that of N1 value. For example, in Lyman series, N1 is equal to 1. In Lyman series, N1 is equal to 1. In Lyman series, N1 is equal to 1. So N2, very simple. N1 is equal to 1. N2, 2, 3, 4, etc. 2, 3, 4, 5, 6, 7, etc. So N2 is always greater than N1 value. So N1 is equal to 1, but N2 is equal to 2, 3, 4. So finally, in Lyman series, N1 value is 1 and N2 2, 3, 4, etc. Next, Balmer series. In Balmer series, N1 value 2. Okay, N2 is always greater than N1. So N1 value 2, remaining 3, 4, 5, etc. 3. So in Balmer series, N1 is equal to and N2 is equal to 3, 4, 5, etc. Because N2 is always greater than that of N1 value. Next one, Passion series. Generally, Passion series N1 value 3. So N2 value 4, 5, 6, etc. 4, 5, 6. So in Balmer series, in Passion series, N1 is equal to 3, N2 4, 5, 6, etc. So Lyman, Balmer, Passion here. Next one, Bracket series. In Bracket series, N1 is equal to 4. N1 is equal to 4. So N2 value 5, 6, 7, etc. 5, 6, 7. So in Bracket series, N1 is equal to 4. Next N2 value 5, 6, 7, 5, 6, 7, etc. Next one, last one, Fun series. N1 value 5, N2 value 6, 7, 6. Okay, so these are N1 and N2 values. N2 is always greater than that of N1. Okay, clear? So in Lyman series, N1 is equal to 1 and N2 is equal to 3, 4, etc. So in Balmer series, N1 is equal to N2 3, 4, 5, etc. Next, Passion series, N1 is equal to 3, N2 4, 5, 6, etc. Next, Bracket series, N1 is equal to 4, N2 5, 6, 7, etc. Next, Fun series, N1 is equal to 5, N2 6, 7, etc. Because N2 is always greater than that of N1. Okay? So Lyman series, Balmer, Passion, Bracket, Fun series, N1 values, N2 values. Next one, spectral region. So Lyman series, UV region, ultraviolet region. Next, Balmer, visible region. Visible region. Next one, Passion, IR region. Next, Bracket series, same IR region, infrared rays. Fun series, same IR region. Very important. So name of this series, N1 values, N2 values, and N2 is always greater than that of N1 value. Next, spectral lines. So Lyman series spectral region, UV region. Balmer series visible region. Fashion series, IR is here. Bracket series, same, IR is here. Quantity series, same, IR is here. IR is here. So it says hydrogen spectrum. Hydrogen spectrum, very clear. Okay, right. Next one. Next one. Next one. Next one. Okay. Formula to find. Formula. Formula to find. Find wave number. Wave number. Wave number. Generally, wave number symbol U1. Wave number U1. And wavelength. And wavelength. Wavelength. So generally wavelength symbol lambda and wavelength of spectral lines of spectral lines. Very important one. Formula to find wave number u bar and wavelength lambda of spectral lines. That means spectral lines, Lyman, Palmer, Passion, Bracket, and Fancy. Very important formula in JEE and NEET also. That is formula to find wave number symbol u bar and wavelength of spectral lines. Spectral lines. Very simple principle. U bar is equal or wave number is equal 1 by lambda. 1 by lambda is equal RH into 1 by n1 square minus 1 by n2 square. N2 square. So this is okay. So wave number u bar is equal 1 by lambda is equal RH into 1 by n1 square minus 1 by n2 square. 1 by n2 square. So in this u bar is equal wave number. U bar is equal wave number. Next lambda is equal wavelength. Lambda is equal wavelength. Lambda is equal wavelength. And very important RH means Rydberg constant. RH means Rydberg constant. RH means Rydberg constant. Rydberg constant. Generally, Rydberg constant value 109,677 centimeters inverse. So 109,677 centimeters inverse. So that is Rydberg constant value. Okay. So formula to find wave number and wavelength of spectral lines. That is u bar is equal 1 by lambda is equal RH into 1 by n1 square minus 1 by n2 square. N1 n2 already know. So u bar wave number, lambda wavelength, RH Rydberg constant. Scientist name Rydberg constant. And Rydberg constant value 109,677 centimeters. Okay. So u bar is equal 1 by lambda is equal RH into 1 by n1 square minus 1 by n2 square. So this is formula to find wave number and wavelength of spectral lines. And very important RH, that is Rydberg constant. And Rydberg constant value 109,677 centimeters. So this is hydrogen spectrum completed. So first of all, spectral lines, Lyman, Balmer, Paschen, Bracket, one series. Next table form, and next one formula to find wave number and wavelength of spectral lines. Important formula in JEE and NEET also. U bar is equal 1 by lambda is equal RH into 1 by n1 square minus 1 by n2 square. Okay. So this is hydrogen spectrum complete. Next one. Next topic. Next one. Next one. So actually 5 atomic models. First one is Dalton's atomic model. Second one J.J. Thomson's watermelon atomic model. Third one is Rutherford's atomic model. And fourth one is Bohr's atomic model and hydrogen spectrum. And next one quantum mechanics. In quantum mechanics, first theory, very important theory. That is Planck's quantum theory. Planck's quantum Planck's quantum theory. Planck's quantum theory. Very, very important theory. Planck's quantum theory. Okay. So Planck's quantum theory explains. Planck's scientist name. Planck's quantum theory explains the black body radiation. Planck's quantum theory explains the black body radiation. The black body radiation. So what is meant by black body? What is meant by black body? So black body means an ideal body. An ideal body. An ideal body which can emit and absorbs, which can emit and absorbs energy, which can emit and absorbs energy at all the frequencies of electromagnetic radiation. Electromagnetic radiation is called black body. So black body means one of the ideal body. Ideal. An ideal body which can emit and absorbs energy at all the frequencies of electromagnetic radiation. Electromagnetic radiation is called black body. Okay, so Planck's quantum theory explains the black body radiation. Black body. So black body means an ideal body which can emit and absorbs energy at all the frequencies of electromagnetic radiation. So this is black body theory. Okay, and next one, quantum. What is meant by quantum? 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 Quantum is just an energy packet. Quantum is just an energy packet. Energy packet. So quantum is just an energy packet, and it has no mass. It has no mass. No mass. Okay. So first of all, black body, an ideal body which can emit and absorbs energy at all the frequencies of electromagnetic radiation. And second one is quantum. Quantum is just an energy packet, and it has no mass. No. And finally, energy of quantum. Energy of quantum. Energy of quantum. Capital E. Capital E means energy of quantum is equal to principal NH nu. So energy of quantum capital E is equal NH nu. So in this N is equal 1, 2, 3, 4, etc. So finally formula E is equal H nu. E is equal H nu. Finally formula E is equal H nu. So in this E means energy of quantum, E capital E, and then H Planck's constant, nu frequency, nu is equal frequency. So finally very important H. So in this H is equal Planck's constant. H is equal Planck's constant. This H is equal Planck's constant, and Planck's constant value is approximately 6.627 into 10 to the power of minus 27 every seconds. And second one is 6.627 into 10 to the power of minus 34 joule seconds. 10 to the power of minus 34 joule seconds. So it says Planck's constant values. Okay, approximately value. So H is equal Planck's constant 6.627 into 6.625 into approximately into 10 to the power of minus 27 every seconds. Next one 6.627 into 10 to the power of minus 34 joules. So this is Planck's quantum theory. Okay, so Planck's quantum theory explains black body radiation and what is meant by black body. Next, what is meant by quantum? Quantum is just an energy packet. It has no mass. And energy of quantum capital E is equal H nu. In this N is equal 1, 2, 3, 4, etc. So E is equal H nu. So E means energy of quantum. H is equal Planck's constant, and nu is equal frequency. And the Planck's constant value is 6.627 into 10 to the power of minus 27 every seconds. 6.627 into 10 to the power of minus 34 joule seconds. So this is Planck's quantum. And next one, very important, de Broglie's. Next important theory, important quantum mechanics. It is de Broglie's scientist name. De Broglie's. De Broglie's dual nature. Dual nature of matter. De Broglie's dual nature of matter. Okay, very important theory. De Broglie, scientist name. De Broglie, scientist. According to de Broglie's theory, electron exhibit both, that is particle nature and wave nature. Electron exhibit both, that is particle nature and wave. So according to de Broglie's theory, electron exhibit particle nature and wave nature. That is de Broglie's. Electron exhibit particle nature and wave nature. Here, so de Broglie proposed that electron exhibit particle nature and wave nature. And de Broglie's principle very important. First of all, according to Planck's quantum theory. According to Planck's quantum theory. According to Planck's quantum theory. According to Planck's quantum theory, total energy E is equal principal E is equal H. Okay. So H Planck's constant and nu frequency. But frequency nu is equal C by lambda. C by lambda. C means velocity of light. Lambda wavelength. So frequency nu is equal C by lambda. So E is equal H into nu C by lambda. C by lambda here. So according to Planck's quantum theory, total energy or energy of quantum E is equal H. So this nu is equal C by lambda. So E is equal H into C by lambda. Next one, according to Einstein theory. According to Einstein theory, total energy E is equal mc square. So first principle, Planck's quantum theory. So E is equal H into C by lambda. So this is first equation. And second one is according to Einstein theory, total energy E is equal mc square, and C is second equation. So first equation is E is equal H into C by lambda, and second equation is E is equal mc square. So E means total energy, m mass of electron, C velocity. C means velocity, speed. So mc square. So finally 1 and 2. So first equation E is equal H into C by lambda. Second one E is equal mc square. So finally H into C by lambda. And nu is equal frequency, but nu is equal C by lambda. So E is equal H into C by lambda. That is first principle. Second one, according to Einstein theory, E is equal mc square. M means mass and C velocity. So mc square. And compared to 1 and 2, so H into C by lambda is equal mc square. C cancel. Remaining H by lambda is equal mc. Then lambda is equal H by mc. Lambda is equal H by mc. So, but momentum P is equal. But momentum P is equal mass into velocity. That means mass into, so mass m, velocity c. So finally principle, lambda is equal h by mass into velocity. That means momentum p. So principle lambda is equal h by. So C is de Broglie's equation. Lambda is equal h by p. In this lambda is equal wavelength, h is equal Planck's constant, and p is equal momentum. Momentum p is equal mass into velocity. Mass m, velocity c. So this is de Broglie's wire nature of matter. Okay, so de Broglie proposed that electron exhibit both, that is particle nature and wave nature. Okay. Next, according to Planck's quantum theory, total energy E is equal to H. H means Planck's constant and U is equal to 3. So U is equal to 3 by lambda. So E is equal to H into C by lambda. First. According to Einstein theory, total energy E is equal to mc square. And 1 and 2 equations, H into C by lambda is equal to mc square. So C cancel. Remaining H by lambda is equal to mc. Then lambda is equal to H by mc. But momentum P is equal. Mass into velocity. So lambda is equal to H by P. So it is lambda means wavelength and H Planck's constant and P momentum. Momentum means mass into velocity. So this is de Broglie's equation. So first one is Planck's quantum theory and second one is de Broglie's equation. Okay. So first of all, 5 atomic models: Dalton's atomic model, J.J. Thomson's atomic model, Rutherford's atomic model, Bohr's atomic model. Next, hydrogen spectrum and table form. Next, very important formula: U bar is equal 1 by lambda is equal RH into 1 by n1 square minus 1 by n2. And next one, Planck's quantum theory. Planck's quantum theory explains black body radiation. What is meant by black body? Next, what is meant by quantum? And Planck's quantum theory is equal to. Next one, de Broglie's theory. According to de Broglie's theory, electron exhibit both, that is particle nature and wave nature. And finally, de Broglie's principle, lambda is equal to h by p. So it is lambda means wavelength, h is equal to Planck's constant, and p means moment. And momentum principle, mass into velocity. So this is Planck's quantum theory and de Broglie's theory, or de Broglie's wire nature of matter. Okay, so all of you practice Rutherford's atomic model, Bohr's atomic model, and hydrogen spectrum. All of you students practice Rutherford's atomic model and Bohr's atomic model. Okay, so this is Planck's quantum theory and de Broglie's theory. And previous JEE means a neat question. Hydrogen spectral cells, very important topic. Next, previous JEE means principle. U bar is equal 1 by lambda is equal RH into 1 by n1 square minus 1 by n2 square. Okay, so this is quantum mechanics. And first one is Planck's quantum theory, and second one is de Broglie's wire nature of matter. And all of you should practice Rutherford's atomic model and Bohr's atomic model. Okay, and remaining class we will continue.